All right, so I'm going to make a recommendation here, is just to thuggishly multiply it out, and then we'll go to the whiteboard and do something different. And if you multiply this out, let me write this down for you. I can get my pen out, and I'll put this right over here. So what would you get? I'm distributing this AB across those three terms. So I get A squared B plus AB squared plus ABC. Now I can do the BC across them. What are you going to get? ABC plus B squared C plus BC squared. A lot of work, right? Distribute this across now. What do you get? Let's see, A squared C. And then you're going to get ABC. And then you're going to get AC squared. All right, this one's done. We'll go to the next one. What's the next one going to be? Minus A squared B. And you're going to get minus A squared C. All right, let's go to the next one. We just did this one. Let's do this one. So it's going to get minus B squared C. Right? And then what do you get? Minus AB squared. All right, let's do the last one, which is minus AC squared. And then you're going to get minus BC squared. Well, I hope you can appreciate there's a lot of cancellations going on here. I mean, this cancels, this cancels, this cancels, this cancels, this cancels, and this cancels. And what are you left off with? Something pretty simple, by the way, 3ABC. And that's what they say over here. So they say easy enough to expand. All right? I'm going to go to the whiteboard and just kind of talk through the next part of it. All right? Now, certainly, the way you do it is the way you do it. Don't think that any one way is better than the other. But Wells is trying to teach something about symmetry in the problem. All right? So what I want to do is go through another technique. All right? You go to the whiteboard. Go to the whiteboard. I unfortunately have to write it down again, which, to be honest with you, is problematic for me because I have to copy it. And give me 1 second to do so. Just give me a minute to do this over here. Get my pen out. Yeah, I'm okay. And what's that going to be? AB plus BC. I'm going to write it as AC, by the way. I'm sorry, a little different than it's written in the notes, by the way. I'd like to keep it alphabetical order. AB, BC, CA, A plus B plus A plus B plus C. And then minus A squared, B plus C, minus B squared, C plus A, minus C squared, A plus B. Yeah, I'm going to erase this guy right over here. Just write it as A plus C. I got to check what I'm saying is what's written down, by the way. A, B, B, C, C, A. I just wrote it as AC, by the way. A plus B plus C. Minus A squared, B plus C, minus B squared, A plus C, minus C squared, A plus B. You know, I noticed immediately there's like a lot of symmetry here, all right? And another thing I noticed is that, you know, I'm going to write this over here. I'm going to write down, you know, that A is a factor of the problem. And the way I notice that is I could write this down as a root of the problem. So I just want to make sure you understand, if I said A is 0, that this thing would be a root, which means the whole expression, this whole expression over here, would be equal to 0. And if this thing is symmetric, B would be a root to the problem, and so would C, if it's symmetric. You're seeing that, at least I hope you're seeing the symmetry. So let me just test it out, all right? I think I'm seeing that. So what I'm going to do is go over here. Give me a moment to do that. And wherever I see, I'm going to say 0. I'm going to erase the other two, but I see that symmetry too. So if A is 0, would you get, you would get, let's write this down. You would get BC right? What else would you get? Well, if A is 0, you get B plus C. And then the next term would be 0. The next term would be minus B squared times C. And then you'd have minus C squared times B. Right? Now, it's a little simpler than what we did before, but what would you get over here? You'd get B squared C plus BC squared minus B squared C minus C squared B equals 0. All right? Now, let's just take a look at that. This cancels. I forgot to write in alphabetical order, but, you know, BC squared and C squared B is the same thing. That goes to 0. So this stands to reason that A is a factor. I'm sorry, A equals 0 is a root, so A is a factor. B would be a root then. I can go through that, but very symmetric. And C is 0. So now I know that A, B, C is in fact a factor of that problem. All right? It's a factor of the problem. So what are we going to do now? Well, it's like, look at another one. And let's put this down. So I am going to claim that this problem here factors into some multiple of A, B, C. By the way, I have no idea what the multiple is, including it's a variable term, a variable factor. Right, because it's a factor of the problem. So let me start to erase things here that I don't need anymore. Erase this business over here. And I need to pick a really easy number to get this to work. A really easy number. So the question is, what's an easy number? I mean, you could choose 0, but then you just get 0 on both sides. But I got symmetry over here, so I'm going to say A. What's a nice easy number for A? I mean, you can make A to be 0. You can make B to be 0. You can make C to be 0. It's super easy, by the way. But unfortunately, I wouldn't know what K is doing that. K could be any real number, any variable term as well. So I could pick something a little bit easier to get the K anyway. And I'm going to pick, I think the next easy number I could pick is A equals B equals C equals 1. And let me write that down. And what do I have to do? I have to do this side here, and I got to do this side over here. And I think if I do that, I'll be able to figure out what the K is. So on the right side, that's really easy on the right side. It's just K times 1, which is K. Now, if I do the left side, a little more demanding for me, but 1's easy. So you're going to get, I'll just do this first. That would be 3. That would be 3. Again, A equals B equals C. Minus, well, let's see what you get there. You would get 2. Again, if everything is 1, 1 plus 1 is 2. Minus 2, that's pretty simple to do, and minus 2 over here. So I think I'm ready to do this. This is going to be 9 minus 6 equals K. So the K is equal to 3. So again, we're getting the same result. 3ABC. That's a simplification of the problem. Thank you.